All right, app workshop, lesson 2, counting from a zero index. Welcome back. This is nominally called file system. And what I've really been interested in trying to do this time is to start elaborating our CLI-based tooling. Not everything's going to be CLI, but we have a lot of CLI. I mean, unless you're going to go build a front end, it's kind of the next immediate accessible layer when you actually build an agent you want to do something with. So what we're going to start doing is we're going to leverage our CLI tooling, and we're going to look at Clay, and we're going to start producing a minimalist version control interface. I spec'd this system out. Parts of it work pretty well. There's at least one part of it that is incredibly slow, and I'm not completely sure why that is the case right now. And then there are parts of this that are left as an exercise to the reader, as that were. But what we're going to do is we're going to look at Clay. We're going to build a CLI agent that interacts with it. We're going to talk about, like, how do you do something like calculate a file diff? What does Clay do for you out of the box versus what you might want to do on top? And then we're going to put this together into kind of a simple version control tool as we do this. Now, let me go ahead and get fake Zod and everything. I guess I don't need a fake Zod yet, but I do need a screen. Okay. All right. That's probably partially blocked by Zoom. That should disappear in just a moment. Let me get the chat window out here so we have that. All right. Visible. We're good to go.
Yep.
All right. All right. So has anyone dug around in Clay before much? You know, incidentally, we've all used Clay because we've done bar commit and bar install and that sort of thing. Clay is Urbit's file system, and what that means is kind of an interesting philosophical question, right? So a file system is ultimately responsible for how you are representing blobs of data we call files. Now, to call it a file is an extremely old metaphor that we are using that, you know, literally harkens back to carrying around boxes of punch cards, right? Like a file was a collection of punch cards that would all go together. What happened is file systems were created on computers as a way of organizing references to these discrete collections of data on disk. And early file systems, you know, you'd have an internal file structure, you know, a bit structure, byte structure for your file, and you'd have a header at the top that would give it information based on, you know, it's a later on music file. But if, you know, if it's an early thing, it's like a bitmap file or something like that. And so there's a header at the top that gives you information about what that information is. But if you were using a system like DOS, then your file system is never even looking at the header. The only thing it knows about what is going on with this file is the file extension. So you'd have 3 characters at the end that would basically let you try and tell the file system what this is. And I haven't used Windows in a while, but at least the last time I used Windows, which was Windows 7, it was still, you know, if you'd rename a .txt file to a .pdf, then it would immediately just, you double click on it and it would break because it would send it to the wrong part of your system to handle this. So It's also a bit odd. So one of the odd things about conventional file systems is that in a sense they're untyped, right? They're agnostic about the kind of information that they are carrying. Another odd thing about them in some respect is that they abstract everything at the level of a file. And there's sort of some question about whether or not file is actually an uncanny valley of data representation. Like certainly you can write a game or something and you have like a library file or an LNDB file or something else sitting around that is collecting and organizing all of your blobs, right? Your binary blobs of information in a way that doesn't map directly to files, right? Like obviously it's stored somehow on disk, but if you want to go access this, you're accessing it through the database representation. It's stored in the database representation. And there's a sense in which at the user interface level, you don't even know about it as a file. You're just saying, go pull this image, go pull this music, go pull this user record and so forth. And so it decouples the representation from the database representation and whatever's actually going on disk. Urbit is currently kind of also in this uncanny valley. And so there's been some discussion about long-term unifying Gall agents and Clay, because as it turns out, there's a lot of overlap in what goes on between Clay and Gall and representing things where, Gall knows about a running agent, what we're going to call a running agent, which is distinct from the file containing the agent, right? We have an app file that contains the agent, but there's actually a running agent in Gall that Gall is maintaining the state and knows things about this agent that are not inherent in the file, the app file from which the agent is derived. So when we think about Clay as a file system, I want you to keep that in mind, that file system is sort of for the time being at least, it's a kludge that we're using because we're still talking so much to an underlying Unix host system when we work with things. So what Clay does, in the first place, is going to manage desks and files. And we're going to include file builds in this process. So Clay needs to know how to access and use desks and files, and it needs to know how to coordinate them between Earth and Mars, which it will do mainly by sending Unix tasks to the underlying runtime to cause it to do things like, coordinate, check, is there anything on Earth's disk that is not known about on Urbit, and vice versa. And then it'll also do file builds, which was the forward vein and is now part of Clay that's been unified into Clay. And file builds are interesting when you think about them, because among the thing that's going on when you do a file build is, at the top we may have something like a FASLA, and we're importing some library. Since this is a wrapper around what's generated in the rest of the file, and it refers to a library that is on my current desk, it means that the file that is generated by a forward build on one desk that is verbatim text of the file, if it uses a different version of the library distributed with that desk than some other thing, those two desks will result in different compiled nouns, right? They will not be actually the same file as each other. And the second place, and this is somewhat related, is going to provision marks, right? So marks, like at this point, what is a mark to you? Like, what do you think of a mark as doing and being? It's not rhetorical. Okay.
I think a mark, you're just changing from data types, right? File and data types, converting one to the other. Right? It could be like a JPEG to a PNG or a text to whatever. Is that kind of what you're looking for, Neil?
Well, I'm looking for what you know.
Okay, that's what I think.
Great.
I thought you're converting file types.
Yeah, so Jack has it as a file type. You have it as kind of a file converter. I think that I'd like to, at this point, generalize that one step more from you. I'll call this a system of noun transformation,
That's good. Yeah.
right? Because we don't actually have to have a file to work with marks. We can mark something, and you'll see this happen sometimes where an agent will be internally using mark names, but there will not actually be a mark file to which they correspond. And as long as it doesn't touch Clay or try to do a transformation, that actually works. Like you can do funny things without actually having a mark file in place. On the other hand, without a mark file in place, without a rule for this noun transformation, things actually break in interesting ways. So if you try to include a file from Earth that Mars does not have a mark for, like an MD, a markdown file, or an MP3 or something, there's no rule for that to go from whatever its, text or binary representation on Earth is to its storage as a noun. If we're storing a WAV file or an MP3 file, like we're just storing a binary blob. Those do not, at the current time, have a particular noun structure the way that a JSON or an XML file does. And so without that noun transformation, or without a mark that defines, there's a png.hoon, there's a jpeg.hoon, there is not a gif.hoon. So right now, unless you go build a file for it, you can't serve a GIF from an Urbit ship as a server. So you have to have that noun transformation if it's going to hit Clay and be stored internal to the system. And then the other big thing that Clay does is it handles over the air updates, right? And it does this by provisioning what's actually going on with desks. Like, how do desks talk to each other? How do they know about each other? How do they diff each other, right? Like, how does one desk relate to another? And so when we're gonna think about Clay as a version controlled file system, we first have to get into what Clay is capable of doing and how it works. Now we can ignore parts of this. We are not doing anything that looks like an OTA update or a desk upgrade, right? So at the level of user space code generally, as long as we are providing the marks that need to be used, I'll call this rules of thumb for upgrades. So you have to have all the marks. You have to don't clobber anything in desk.bill, right? You don't want to change desk.bill in a way that overwrites something in base in particular, because that'll break things in interesting ways. That's more. Does anyone remember Park, which was Matilda's fork of the garden desk? And then it wasn't maintained forever. It was trying to solve a specific problem that Garden had that I don't recall offhand what that was anymore. But people who installed Park at some point had to go back and do some manual reconfiguration to switch things back to Garden, because the way that Gall runs, you can only have an agent with a given name running at a time. One agent with a given name running at a time. And so the Park versions of those agents were masking what the Garden version of those agents would have been. And so when Garden superseded Park and Park was no longer synchronized, this is what happened there. That's probably the example that's most salient to everyone running in here. The other thing that happens is if you bar merge from base when you produce a new desk and forget to change desk.bill, then your fake Zod will be running everything from the new desk, and that can break things in interesting ways too. Another rule of thumb, let's see. So you want the marks present, you want to not clobber anything. As long as you have on load properly defined, things should be able to upgrade. If you forget this, then again, things will break in interesting ways because there won't be a way for the upgrade to actually apply on the new desk. Okay. And this is kind of a mix of things that Clay does and things that Gall does when it runs into this. Clay tries to pull in the desk and upgrade everything. And if it can't successfully upgrade things, then it won't pull in everything that you have. And so I'm sure you've run into this situation with development where you have like a syntax error in some file and you're unable to commit anything else until you've solved that syntax or type error to get things to run. All right. We are going to deal a little bit with provisioning marks, and I'm actually stuck on an interesting problem in my development here of this program that I didn't quite get resolved before I came back, because it's actually a moderately difficult problem in Hoon to solve. It's not impossible. I've got a lead on it, but it's an interesting mark problem. And then mostly we're going to deal with desks and files. We're not going to deal with file builds today, but we're going to deal with desks and files. All right. So let's go to the 10,000-foot view of what is going on in Clay. All right. Clay maintains its vein state as what it calls a raft. All right, it's a data structure which is primarily aimed at being a file database. It's going to think of the world in terms of the domestic files that it knows about, which are the rooms here. These are going to be organized into desks. Hoi, this map of ship to rung, these are something else. These are the foreign ships that we are watching. Kids, notably, which is what we sync our base desk from, is the main thing that we do this. But anything that we bar install is ultimately going to end up in this. And then RAN is the object store. And so what that means is that when we store, and then there's some other things in RAF too that I left out here. When we store a file as a noun in Clay, we access it via a path, right? So access is brokered via a path, but the path doesn't map to anything real, right? Like it's a label, it's a convention that we are using to access a particular noun, and that noun is actually stored as in a hash table. Like there is a table of hashes, which are basically pointers to the nouns. So if you know that, so what you do when you're looking up a file, when you're scrying into Clay, for instance, into the bound namespace, you're looking up a file, you're using a path to look up a hash, and then you're using the hash to look up the actual noun. And so Clay is kind of this single level data store that just has this bit there. Now, once we have that information, we're going to look at like what is actually known in a desk. Room, by the way, room right here. Room is a map desk dojo. Desk is a name. It's a label. It's a TAS. It's a term. So your room, your domestic desks are simply collections of labels, names of desks to desk states, which is a dojo, which is an overloaded term because it has nothing to do with the command line dojo that you are familiar with. All right. This is where it knows about things like your cult, which is your collection of subscribers. There's some pretty good jokes if you get deep down into the kernel with this stuff. You know your desk state, and then you know a lot of permission stuff, and like I don't even know what the fizz melt stuff is. I've never really looked into that. Yeah, whatever a mega merge is, I guess that would be a lot of files changing at once. What we really care about is the desk state, the DOM. And one of the downsides of trying to dig into this is that things are posted in a zillion different places. All right, because there's Lowell and there's Zeus and there's Clay and there's Arvo and there's Hoon and the actual file, like the type definitions are scattered everywhere. So here's your desk state. I believe that onks are no longer in use. This is the other thing, is some of these types are still kind of in churn. So I think this comment is actually out of date there. But these are like the things that are known about in your desk state. And so like, what are these kinds of things? All right, so we have like an eon, which is like something about our top level state, right? The kind of thing we are. We know this map of eon to taco. We're actually going to be interested in tacos because we're going to use those basically as the hashes to look at files in a little bit when we look at this. We have labels, which are not used a whole lot right now, but we will start to use these more. We're going to start introducing these. Probably, did I include? I did not include the type. Okay, so all right. So when you here's some. All right. So what is a beak? All right. Well, sometimes we do things like we write a beak this way. So what is a beak?
Ship, desk, and division number.
All right. So we have a ship, we have a desk, and then what's that?
Was it revision number or time?
Yeah, revision number or time. The super type is a case, but I think we just changed that to a cast. Something about this is changing right now with 413K. And I think I want to talk about cases in the current one, no longer cases. Cases are like moved out of Clay into somewhere. So anyway, they're mucking around with this right now because they just added a new way of looking things up. But what this is, and this is important because most of the time we use a timestamp. And what a timestamp does here, this is a type union. So if it gets a timestamp, what it does is it looks at the most recent version of the desk prior to that timestamp. Has anyone ever used a timestamp other than now? Like, probably not, right? Like this isn't a thing we do that often.
In the chess code, they have like there's like this to help against like collisions of like the exact same time by millisecond. They like we add a little bit of, or like the original creator added a little bit of entropy at the very end.
Okay, just like a sub-second amount of entropy there to, yeah, kind of bump it around.
Yeah. It's kind of odd. It's weird to work with.
Yeah. Sorry, I'm messing with my audio settings because you're really quiet, but that's okay. All right. All right. So, okay. So, all right. So there's a case of someone bumping timestamp in real life. A revision number. All right. So a timestamp is a PAT DA. We have a revision number, which is a PAT UD. This is what gets reported when you bar commit, right? It goes from 2 to 3 to 4 to whatever. It starts counting at 1. Your base revision number is 1, not 0, and it will break things in interesting ways if you have a 0 revision number there, as I discovered. But if you give it a revision number, then you're actually talking about like a particular commit. So this is sort of the thing that's most analogous to referring to a commit hash in Git terms in current Urbit usage. Because this is so particular to the desk that you're working on, that's another reason that timestamp is kind of the most useful thing that you have there. One of the barriers to using Clay as a Git or GitHub style repo replacement, I think, is sort of figuring out how to coordinate like different revision numbers on different systems when we build this sort of thing out. Timestamp revision number, label. All right, labels are almost not used at all. We're going to use them today just to start taking a look at what's going on, but it's kind of like a tag in GitHub, right? Like I can name it as a release or something like that. And in principle, I could distribute things to people on the basis of what release they're getting, or I could trigger it being copied from one desk to another as a, like there's a develop desk and a release desk. None of this exists now, but you could do this. And then with 413 Kelvin, they are adding a new type, which is a hash, which is a pat UV. My understanding is that will make it easier to work with remote scry lookups for values. So it's also going to publish a hash of the desk, and then you'll be able to, or a hash of the desk state at that point, and you'll be able to use that to access things. Yeah, so the main, what we end up with, the long and short of digging into what an eon and a taco and all this stuff is, we basically resolve this to our fundamental data type of a file database is a map lobe page. Like within a desk, it's a map lobe page, or a lobe is a pat UV, it's the hash. You have a page, which is a cask. And then you have a lat is a map. Okay, the lat is the map load page, and we already know about the map load page, so we'll leave it there. So your fundamental data structure is going to be this map from a hash to a cask. So what is a cask? Remember what a cask is? I know conceptually, but I actually don't remember. A cage is a mark in a vase. Is a cask a mark in a vase too? So yeah, it's a mark and a noun. That's right. It's not carrying around the cage information because it doesn't have the vase in it. So yeah, it's a mark and a noun. That's right. But what this is interesting. This is the place where basically the reason why you have to have the mark defined in MAR in order to include the file on the desk. The cask won't resolve if it doesn't know what the mark is that it's using in the data builder when it does this. All right, so we are going to use these things when we talk about commits. So a commit in Hoon is a yaki. There's a taco and a yaki, and I think these are like Japanese food. Taco's octopus. I don't remember what a yaki is, but this is a commit. And so the commit has a list of parents, which is generally pretty simple because there's normally just one commit. Okay, so yaki is fried. Okay. Takoyaki is fried octopus and calamari. Okay, interesting. Normally there's one parent because we haven't been doing a lot of like actually treating desks as branches, but in principle we could. Like one of the interesting things about Clay, I make this argument about marks too, but also with Clay is Clay feels like it's underutilized internally. Like we haven't had to do things that use a lot of the internals of Clay, but Clay is surprisingly complete. Like there's a lot of bits and pieces in here that do specific things for us. So you can see that list of parents. You see the namespace as the map of path to lobe. So that's actually how we're actually going to be able to look up the lobe values in that map lobe page up above. Anyway, so this is how we're going to build these. Now, if I want to actually interact with Clay, then I will do a scry. So it'll be a .ket, and your standard form for any .ket is you're going to give it a mold as the first argument, like what's the kind of thing it's giving back. And you can actually do anything that will correctly map, any mold that will correctly work here. There's rather a bug in I don't know if it's in Hood or in Dojo itself exactly where it is. But if you have a malformed scry, then your Dojo will break, it will reset, and you will need to, you'll lose your scroll back, which is the most painful part of that. But this will also happen if you have a malformed scry inside of a Gall agent for some reason. So malformed scries just get you in trouble when you're working with this. But what we're going to do here is we're going to do a pat T. We're going to do it with an X care. Clay has more cares than any other system. It has probably more than 12 cares that do various things for you. And we're going to give it the specification here. All right, so there's a file on my system, which is the cat generator that does something fairly similar to what's going on here with that pat T. And if I did this correctly, this should just print. I don't know why it's being sluggish. If I did it incorrectly, then I'm getting a huge scroll back and things are really going to break. But maybe this is just an old fake sod and it's not one I should be working with so much here.
Mark at the end.
Well, I have the mark. I have Hoon.
Oh, okay, right.
I don't know why it's sitting so long. Shouldn't be doing any sort of fancy transformation there. I'll let it sit for a moment and make sure that that's behaving properly. All right, so Clay at one time in the past functioned like Git and other version control systems and stored file diffs as well as files, right? So a diff is the list of changes. And so a system like Git stores the current version of the file, and then it stores a past history of diffs or file deltas so that you can reconstruct different points in the past history. At the current time, Clay only stores entire files or tombstones, right? So you can tombstone something if you don't want that information anymore, if you're trying to clean up your desk. And there are various tools that are gradually getting built out. Like we're getting bigger looms at the same time that we're acquiring the ability to actually clear out parts of our looms. Did this work for anyone else, like quickly? I think this fake sod may just be a bad fake sod. I'm going to use this fake sod and see if that works. .cat pat T send cx tis gen cat Hoon. Yeah, okay, something's wrong with that other fake sod. I need to just clear it out because this worked immediately. All right, some interesting things that unless you've worked directly with files before, we'll also just cat the file itself so you can compare. All right, so what are all these FAS0As? What are these doing for us? Like by visual comparison. Yeah, these are our \n's. We are the tape and chord escape format for Urbit. They made the decision, which breaks compatibility, but otherwise does not seem like a bad decision, that you will actually not specify like a \n or a \t or whatever. It actually specifies the hexadecimal of the control character to which is being referred. So this is a C style \n, but it is literally the control character hexadecimal A in ASCII. And so that's what's actually displayed and stored here. It is a \n. It will, like if you were to process the same file somewhere else, then it would show up as a \n, but it will display and parse differently here. Okay, so this gives it to us as a chord, as a pat T. So it has some way of converting this information to a pat T. If I look at the actual file itself, the file is interesting because as a say generator, it does something different. What the say generator does, first let's look at the actual scry that it has here. So what is this scry doing? It's kind of an odd scry, but it's worth comparing for what we're doing with the clay here. All right, so it's going to cat 3. No, sorry, this isn't the scry one. This is the scry one. All right, so what does cat 3 vein do? Where did vein come from? What's going on with cat 3 vein? Sorry, you're really quiet for me and I need to. Can you say that again? So what is cat 3 vein? There we go. Yeah, sorry, I'm odd audio. It's not removing the sen because this is the type marker and the actual value is G or C. It is concatenating them together, that value. So this is producing sen CX, like CX as a term. Kind of a weird way of doing it. You probably didn't realize that you can actually, in principle, cat into Gall and display something, but there aren't any I think there's no arc handlers in general in any of the Gall agents, and so this actually doesn't work to use this to scry into a Gall agent, but in principle you could if someone went and built an arc handler for a Gall agent. Loading the path, giving us this back as a noun, right? It's doing nothing. It's just generically handing this back. Then there's an interesting file called pretty file, and this actually parses things up into a nice formatted text tree. We will incidentally work with formatted text. It is interesting. It does some useful things. If you did the first version of homeschooling, you've run into this. Otherwise, you probably have not. Schwa says 3 is related to the block size being 2 to the 3rd. Yes, so we're concatenating at the width of a byte, is what that's saying. And it's a pairwise operation. Rose leaf stuff is, and Palmer tank annotations. This is like a, I'd have to go look at my notes on this again. One of these is like prefixing or surrounding values, or like, so it infixes the values of so like a leaf is a simple tape, and then a rose is an infix value that's around both sides. So it's delimiters like parentheses or whatever that get added to the left and right side. These are mostly used in building formatted stack trace outputs. And so the other interesting thing about this at the end is that we're going to flop this because it gets built in the other order, and we have to output this back as a proper order tree when we output this. Main thing I wanted to look at was just, here's your dot cat. Here's the bit here. All right. Now the other thing, let's come back to molds. All right, so most of the things we're going to need to talk about 4 different cares in clay to build what we need to build. SendX is the first one. SendX just shows you here is a resource directly transformed by a mark and a gate. You have to have the gate and the mark on the end in order to validate a SendX. SendY is going to give you a directory listing. And then we're going to look at W and S, which are going to tell us about the final revision number, the current state of a disk or a file. So we'll come back to, and we're going to talk about F because F is used with building gates here. All right. So what a gate does in this case, when I was pulling things out before, I was pulling them out as a hoon, which is just a pat-t. This is because a hoon file, although it is a plain text file, it just wants to treat it as a single chord because that's what the parser is built to handle. It just processes chords. When we load something through the text mark, for instance, it would get loaded as a wane. All right, so a wane is a list of chord, and a wall is a list tape. So a wane is a list chord. So what we're doing here is we're building a transformation gate, a mold that speaks to these two types. We give it an F because we're building a static mark conversion gate. And then we're specifying that we're on the current desk, like in the current desk at the current time. We want to mark from whatever the marks, whatever the desk's JSON mark is to the desk's TXT mark. And this path will exist inside of FASMAR, FASJSON.hoon. We will have a way to do it so we can do things using this mark now. So what this will mean is that we'll be able to give it a JSON message, like here is a chord message, hello Mars. We'll pass this into DJSON HTML. This is another thing that is changing imminently and will look like this with 413 Kelvin instead of dhep JSON. This returns a unit because it can fail to parse. So if it fails to parse, then you get a nullback. So we need to do a need on it because we want it to crash if it fails to parse. And then we pass it to a JSON to text gate. Let's do it without the JSON to text gate first, just to see what that looks like with this mark. Like if we're actually going to build a mark, what happens when we work with it? And then we convert that JSON to a text, and we see that we can, in fact, round trip it here as a wane, as a list of chord. Right, so that's the value that we're actually getting out there. So if we're going to build a mark to convert things between what's going on, this is our basic approach to do it. If you go look at the docs on marks, there are a lot of ways to build marks. In user space, you have to write marks, but you rarely need to manually build marks. Since we're talking to Clay, this is a capability I wanted to build into our version control agent that we're going to be building that runs on top of Clay with moderate success at this point. Which means no success, right? Which means failure in real world speak. All right, let's see. We'll come back to there's some more on marks in the notes, but we're going to skip over that now. All right, so version control system. All right. So what is a version control system supposed to do? All right, so I know you've probably used Git. A few of you have used Mercurial or SVN or some of the others that are out there. Well, like, what's the point? What is a version control system trying to do? No one's going to bite. You can talk to me too. Okay. So Jack has it as let you update your files, but still see the old ones. All right. So one thing is it maintains what I call a provenance, right, or a path. All right. Related to that, it lets you track authorship, right? This is get blame, right? Like who actually made the last thing. SVN had SVN praise too, in case you didn't want to blame someone if someone wrote a good line of code. Git tends to take the pessimistic view there. All right. So it lets you maintain the provenance and it lets you track authorship. And then to some extent, just as the fact that you can set up a repo, it lets you distribute code. All right. This is the way that everyone has been using them largely to date and what they've been built to manage. What Clay is going to add to this, all right, Clay is a system of referential transparency. All right, so a request must yield the same result for all time. The only exception to this is tombstoning, because you can have a resource become unavailable subsequent to publication. Because of referential transparency, so these are your actual scribe bindings. Because of this, you have built-in versioning. All right, so because Clay has referential transparency with a globally addressable namespace and scribe binding, you get version tracking for free, essentially, with Clay at that point. This was intentionally done, but this is like the underlying concept that leads to this. A big one, and one that I have seen in research papers but never seen in a production system besides Clay, is that Clay has typed data. Right, like Git knows about a text file versus a binary blob. But Clay actually, because we have marks, we actually store all our data ultimately as a noun with type metadata attached via the cask. So we get typed data with working on top of Clay. And then, as I mentioned a moment ago, we get a globally addressable file system, right? So we can always refer uniquely to a particular value. Yeah. So when we're building a file system, if we're going to build an agent on top of this, which is what we're going to do next, we actually don't need to do some things. We don't need to produce like a file diff to store a file, right? We will create a system for producing a file diff outside of Clay as part of this, but we don't have to, right? Like, I mean, it's useful to be able to see like, how did a file change? But you get that with Clay. And it's just a matter of, how do we display this to a user in some reasonably accessible format? All right. So we're going to follow in Linus Torvalds' footsteps. He joked that he named all of his software projects after himself, which gives you Git, which is a British boarding school slang term. We're going to call this one Pratt. All right. We are going to aim to have this be able to do the following things. We want it to be able to, it's going to be a CLI agent. We want it to produce the current version of a document. We want it to be able to, I say maintain, but I think I'm going to change that to produce a history of the document as a series of diffs. Okay. And then 3 is kind of the next, like related to that, right? Like calculate the net changes between 2 revision points. How did this file change? We want to be able to produce a historical version of a document. So that's closely related to 1. We'd like to be able to convert the file between marks. We're going to use a tagging system and so forth to do this as well. All right, so the question in the chat is like everything except 3 is already done by Clay. Yes, but also what we want to do is we want to wrap things in a way that a user doesn't have to remember a scribe, that they can type a command like in Git, you don't want to even remember the commit, right? Like you want to be able to type like git diff head tilde 1, right? And just have it figure out what the current head commit number is and what the previous, what the commit parent was, and produce that value for you. Right. So this is what we're going to start doing here is thinking about what these, like how do we make this actually useful to a developer? And actually, we don't get everything except 3, right? Like Git no longer stores diffs. So Git Clay no longer stores diffs. I can get 2 versions of a file, but I can't diff them inside of Urbit right now. Like Clay doesn't give me a way to diff them. Right, so I don't get 2 for free either, but we will look at a way to do that. So we're gonna call this Pratt, and what we're gonna aim for is that we're gonna be able to give it. There'll be like a Pratt bound prompt, and we'll be able to type something like give a path, and then parse it into a value, and like this would give us our output here. I called it give, and then I actually ended up changing the name to draw. They're all four-letter commands, because we're cargo culting kernel space into user space. And we're sort of thinking analogically with Git for what these are doing. But Pratt overlays Clay, so there's no Git init equivalent, right? Like every desk will just validly work with this. There will be no git add or git commit equivalent up front. We will introduce the ability to tag or label. I guess git tag is closer than git commit when I'm thinking about this, but we will have that capability as well. Draw works in the current version. It's pretty straightforward. List works. Diff works moderately well. Span is the one that I got stuck on for an interesting problem. And there's an interesting reason why this is not straightforward to do, even though writing a mark is pretty straightforward. We'll come back to that in a minute. And then labeling a given commit is an interesting one. It works as well. So we don't actually have to have any internal state in Pratt. It doesn't have to maintain its own information because Clay is a typed and timestamped file system. So we could imagine having some internal thing for maybe maintaining commit messages or something, but it turns out that this has also actually already been written for Clay. It's called Story. We'll take a look at Story briefly later on. All right, so we're at about 55 minutes. We're going to start getting into the meat of the CLI agent now that we've talked about Clay. All right. All right, so we're going to have a serve file, and I will share the actual code for all this with you in a bit. All right, so it's going to be an action. It's going to take a list which accepts a path. You're going to be able to diff a path between 2 numeric versions of the file. So these are revision numbers. So I probably should have named them eons or something instead, but oh well. We're going to be able to draw, which draw just prints the actual path right now. Draw is kind of the simplest one. We're going to start working on span, and then name is pretty straightforward as well. All right, the mark, we are going to need a mar Pratt action type that doesn't do anything interesting at all, just like your regular standard. Here's a converter built in. All right, we do need to think about a parser, right? Like what a parser would actually need to do. Let me change my share. And I think I have VS Code pulled up. Yes, I do. Okay. Excuse me. All right, let me. Okay, this will work. All right. So we're gonna have a parser. This is not the most efficient way to build a parser in one respect. It works, but there's a criticism I can make that I didn't have time to fix before I came in here. All right, so if we're gonna parse list, we're gonna parse the word list. We're gonna expect a space, could be more white space, but we're just gonna expect a single space. And then we're gonna expect a stap, which is the path parser. So that's what would come out of this. The criticism is that I should actually be throwing away the white space, and I just want that, because the only thing I care about actually is that I know that I'm getting a list in the structure file, the head tagged type, and that I'm getting the path that's associated with it. You actually notice that I got rid of the pax tis path as well, made things a little bit easier. So right now I'm actually matching this, which means that when I cook this, I have some awkward chords that I'm just throwing away that in a second pass, I'll clean up this code and I won't have to worry about that. But right now I'm parsing everything and passing everything in to the values here. Diff will parse a path and then a numeric value. So demcol ag is the parser for a number, for like a pat UD. It's actually not even a pat UD. I think it will actually parse, let me actually bar exit that Zod, because that was the good Zod. That was an RPN. Okay, so if I scan 1, 2, 3 dem ag, that should just work. Let's see how it treats a. Okay, so it looks like it actually is a pat UD style expression, which is fine because at least at this point we aren't really running into revision numbers that high on clay. Okay, draw is going to parse out a path. So is our parser for a term. So it'll parse a pat TAS out. And then I'm posing all of these together. So plug, so mixig builds a pipeline. Plug handles these sequentially. One is handed to the next. Pose handles them in any order. So it won't hand to the next one when one of them fails, but it will try to do each one of them. Then we started messing around with cook before. We didn't do a whole lot with it, but the idea of cook is that it is, so I'm building arms here. Cook is going to apply to a gate and then a parsing rule that underlies it. So what it is going to do is it's going to take the output of this gate and pass it into, or excuse me, the output, it's going to take the output of this parser gate. It's going to pass it as input to this gate, which is why I have to catch and throw away the space, unfortunately. And what this is going to do is, in this case, it's going to head tag list_r and spit that out. So that does give me an action prat value out of that. So I'm going to write a parser like that for each one of these. So my type coming out of this expression is going to already be an action prat. So if I parse something with command diff or command draw, it is already an action prat. It has that type associated with it. And then I'm going to pose all these things together as parsers. So the idea will be that I will be able to, I'll be able to do something like scan. Etch was a previous name. Name is what that became. So if I scan, then it will give me these 5 values back, and I'm throwing away the spaces because I don't want the spaces. Like I say, not great, but we can work with it for now and throw them away later. All right, and then I'm actually getting my last value back, the name as the pat TAS in this case, label me as just a raw noun, and I will parse this back into something when it, or a raw atom, and it'll come back as a value in a minute. All right, so we're going to be able to use this to cook our results together and get something out. some of these are pretty straightforward. So if we're going to draw, which as you'll recall was the draw will cat the value of the resource. So this is going to return a Wayne. I decided to work in Waynes. Wayne is a list chord. So not a list tape, a list chord. So what I'm actually going to get back here of the value at the path. And then what toWayne does, toWayne called format, this will break it at new lines and return to me that list of chords where every chord is a line. All right, so this will give it back to me as a Wayne, and then once I have it as a Wayne, I can decide what I want to do with it. Inside of my agent, I'm actually not going to do anything special with it. I'll just have it sitting there for me. It's probably worth one of the shortfalls of the current version. The user actually has to specify the entire path, including the beak, to make this work. It would probably be nice if the beak were filled in unless they wanted a particular revision number. Well, I guess draw is automatically the current revision number, but there's some user experience stuff that's worth punching up here. All right, diff should show the diff of two versions of a file. All right, so a diff is a data comparison which gives you, let me find what diff is the one that I wrote here. Let me actually even go to here. All right, so what a diff is going to do, it shows you the differences between two data structures. All right, so file one could be like, this is some text to delete. File two would be, this is changed text. And then the diff of these would be, this would be normal. A lot of times these are marked some way, so I'll put a tar for unchanged is, and then I guess minus some plus changed plus to, or hep delete. All right, and tar text. All right, so if you were to go run git diff or something, it would display the information this way. So we actually have to calculate diffs. Most diff algorithms out there, although they would work generally like character by character, are built to work over lines, because a line is a convenient format for displaying diffs between two files. And so our longest common subsequence is the thing that we're looking for. And in this case, it's this is text. So what it's going to do is it's going to find the longest common subsequence, and then it's going to look at a left-hand side, which will be our old revision, and a right-hand side, which will be our new revision, to produce a picture of the text. The libdiff, which I give you here, this is going to implement an LCS, longest common substring algorithm that, let's see, I have no input, so I should be able to just do this here. Paste it here. All right, and so what this is going to do is it's going to retrieve the base text, it's going to break into constituent lines, it's going to recursively check if we're at the end of either sequence. Otherwise, it's going to do like this recursive thing where it checks heads and tails against each other. It's actually kind of a nasty little piece of highly recursive code with a lot of different recursion points as we go through this. Yeah, I think it could probably be written more compactly than this if you wanted to, but it does what we want. And so if I were to, I guess I need to do col diff. So all of these are. Hold on. I could probably get rid of, what did line break return? Line break returns a wall. I could probably replace this with a turn and a to wane to simplify things slightly. But anyway, like if you look here, I gave it hello Mars, and it returned to me the line Mars because that's the only common line on both sides. There are some other, actually, what it is, TISCOM, does that unwraps? Yeah, there we go. So TISCOM unwraps a namespace so we can access what's inside of it. All right, so we have a working diff library that will do something for us here. So in Pratt, what that ends up looking like is list revisions. So this is going to take a path. And how was this? No, this isn't list revisions. I want diff files. All right. Which has some sigpams in here because this is, I think that what's happening is least or longest common substring algorithm with all those recursions gets very long, like in computation time for larger files. And so it's, I think because there hasn't been any like tail recursive optimization or anything like that, my naive implementation is probably not remotely efficient enough to actually work here, but it does work and gets these values. But anyway, so you give diff files the path and then the revision numbers that you want. And so what we're calling our left path is the first two elements of our beak with an interpolation of our desired left-hand version, and then everything else on the right. Actually, kind of a nice little statement there. So the col gives you a mic col, so you can weld across multiple values here. Part is the same thing, and then right now we're sigpamming those. We'll come back to that later, and we don't actually need to do that. Then we're calculating the left-hand side is. Okay, this first part is an existence check. I said there were more chars we need to look at. So send u, a u char is an existence check, whether or not this path exists. This path does not exist, then we just want to give the bunt because it's the whole thing. It's been tombstoned, or if it didn't exist yet at that time, then we don't have any way to do this. So just do it against the bunt. Then we do the right-hand side. Otherwise, what we're going to do is we are going to take the chord of PAL, we're going to convert it to a wane, and then we're going to trip that to convert it to a wall, which is a list of tapes. And then we're going to do LCS diff on that. Yes, okay, so this works the same way as what we had before, but the new thing here besides the diff algorithm is the send u char, right? Check for existence, make sure that it's there, because if it's not there, you might have an interesting problem and things will crash because your .ket scry will fail. And then I have these two wall to wane and wane to wall. I don't really need these. I could just do these with the turn trip, but I left them in. Okay. Then list revisions will do the same thing as draw file, but it will do it for all previous versions. It doesn't show diffs of these. That would be a better way to do it, but right now it would just report for every previous version what that file looks like. So we just spit out all of them. There's also an existence check. It starts counting at 1. So if it doesn't exist yet, then we just increment until it does exist, at which point we start consing together. SNOC is a reversed cons we just start consing together the values by appending the new .cat scry to our current block, and then output that. So that one's fairly straightforward, I think. Okay, so span is an interesting one, and span fails. All right, so what we want span to do, let me see, I think. Where? Oh, it was Comet Garden. Okay, this one actually has Pratt working, so I can switch to the Pratt command line. That was me. All right, so if I list a file resource, then it'll grind on it for too long, and then fail for some reason. Are you failing? You'll notice too that because STAP doesn't resolve TISs, this is another shortcoming. STAP doesn't resolve TISs, so I'm actually having to explicitly write out the whole beak, which is a bit of a thing. Okay, great. Now it's this is a Comet, so it's now upgrading, and I can't actually show what it's doing there. This may actually have just run afoul of the 4.13 update, and because of the way that CAS and case have been changed. So I'll take a look back at that in a minute. The other thing I wanted to show, I wanted to go back to marks, because that's kind of the place things are stuck. All right, so the idea of span is that I should be able to say span, give it some name, GenCat Hoon, and then give it a different mark that I want it to convert to. Okay, I'm giving it the implicitly, I'm giving it the first mark on the left here, and so I'm giving it the target mark on the right. Where this foundered, let me find the actual code that I was working from. Okay, where this foundered is that writing a mark conversion, right? You want to get a path, and you want to get a 2 as a pat TAS, and you could say something like from mark is rear path, right? So this is the end of the path. Let's actually cast that as a pat TAS instead of a pat TA. All right, so we have a 2 and a from, and then what we'd like to return here is whatever this is, and then a send CF, and then the path, right? And so the issue, well, I'm calling it path, but what it really is from 2. So this is actually, we'll call this we'll call that our mark, and then what we want to return is anyway, we want to apply that mark. So that's a mark gate, and we want to apply that to the .cat of the from gate and so forth. All right, so the problem actually is that when we did a mark conversion before, the mark had a gate to which it corresponded. And the problem here is that if I'm only specifying the mark, how do I know the mold that the mark outputs? Does that make sense? Right, so my earlier statement was the text to Wayne thing. Let me give you that code again so you have that ready to hand. All right. So right here, so basically the question is, I'm building this buckhep mold gate on the left-hand side, or excuse me, buckhep mold gate from JSON to Wayne. But how do I know that TXT returns a Wayne? Right, like dynamically at runtime, if I don't know the mark that is being typed in to span, how do I know the mold that I'm trying to get out of that mark? And it's kind of a nasty little problem because most of the time we're dealing with this at compile time when we do know the answer. But when we don't know the answer, so one solution would be to actually provide that information, something like this. And then it can use that to resolve the names of these gates against the namespace dynamically. That's also not like super trivial, but you can do that. What Joe Bryan suggested looks like this, which is a, so that would be a SendCB in the sense that I have here, that I'm looking at a dais. So I'm doing a CB build, a char B build, and I'm getting the P of the mold of the veil of the dais that I'm getting out of this arm, or that I'm getting out of this mark. And I have not yet managed to do this in a nice way and get this to work correctly. So that's where that one is a little bit stuck. The other one that we're going to look at is name, which is like, how do we actually label a value here? See if this comment is still baning. This is going to have us pass a task to Clay. We don't do this very often. So there's actually an existing label generator you can use, and it would look something like this. There's a bar label. You give it the desk, and then you give it a tag, and it labels the last commit on that desk. So this can, I named it tag 2023-0504. What we're doing here is we're constructing an info card. Info is normally used to insert or delete data to Clay, to insert or delete files. But in this case, we don't have any of that. So what we're going to do is we're going to get the desk out of the path, which is simply getting the head of the path, which I wouldn't even have to do as a snag, but that's fine. And actually, this will fail if I don't do a what sig, I think. So I'll have to deal with that in a minute. I had some version of this compiling. Then there's a send bar. What is a send bar? This is your mental Hoon parsing skills. Yeah, it's a no. It's a no, not a yes. But yes, correct that it is a constant. So it is a constant bar, which is a false. So that's a false. Because I think this is saying that we're not changing a file. We're changing something about the desk. Is what that is a flag for. It's a toggle. Yeah, I know it's a pain. Basically, the reason we're stuck is because we are stuck with the ASCII character set, and we want to minimize keystrokes. And so, like you can imagine prefixing these things with like, I don't know, maybe PAM or something instead. But like there aren't that many, and most of them are designed to be URL safe too. So there aren't that many options we actually have to try and do something with this. So Hoon is heavily sugared, but there just aren't that many options anyway. And then get Eon is getting the actual revision number out of that. So we're going to pass it a task if it lets us run and do this. This is actually also, I think, a pretty exemplary use of a barquette, where you're sort of using the barquette as a way of doing a quick on-site encapsulation, where you're making your code more expressive by introducing getDesc and getEon, but they're not useful generally. I don't need to put them inside of the parent core to make this run. So we're going to pass this card to Arvo as a task to Clay to carry out this operation. The actual agent also doesn't look like much, because the agent is simply a command parser, which returns a toggle on stag and action col_prat, which is already produced by parser in pratlib. There's no internal state or anything, like all my boilerplate is just empty here. Remember what the stag, the PAM, and the bar did for us? That lets us flip between. If a PAM means as soon as we've typed something valid, would it automatically get parsed? Versus do we want to wait until return is pressed? Yeah. And then on command is also pretty straightforward, because every one of these, so in this case, we're getting tape from draw file, and then I'm outputting it as a formatted text instance by ramre leafless tape. I mean, it's kind of a monster of a little statement here, but I'm getting a tape from ramre leaf of tape, which I guess I could skip by just doing a tape. And then I'm cripping it to a chord, and then I'm outputting that. This is doing some version of that as well. List, diff also. This is why we're getting a Wayne back, I think, in every case. So actually, I should probably, is this a tape? Maybe it's a wall. I should double check that. It compiles, so I don't know why it would be a problem, but anyway. And then, yeah, I was having some trouble getting name commit to correctly parse, and then span is stubbed out pending getting the marks to dynamically load at runtime, hopefully without also specifying them in the command line. All right. So this is an agent that starts to implement like what it might look like to do this on top of the system here. Now, there's another interesting system underlying that we can use called story. And that's Sir story. This is lib story. Story is actually a collection of generators in hood. No. Oh, it's lib. Gen hood. Story init, story remove. Okay. So what story does, okay, so I could say something like bar story init. Let's do it for base if I don't specify anything else. It'll create a story file. What a story file is now every time I bar commit, I can also do bar story write and add a commit message to do this. We should probably at some point, oh, this is the old version. There's an old version that's in the pill right now. I updated it so it actually runs. And as soon as that PR is merged, which will probably be in the next general OTA after the 413 Kelvin one dust settles. But what story does is it lets you, bar story write. This is a commit message would let you do something like this, and it'll fail because of the no op thing. And then I'd be able to do less story read, and it would give me the history of known values in this. Yeah, error, no story file found. So this was built a while back, which is why I needed an update to not use the old no op task that Dill no longer has. But I think we have the elements of something promising here, where we could actually build out a better, like actually useful revision control system on top of Clay that we can maybe start to use for a general purpose set of tools, right? Like, can we actually treat Clay like a GitHub? I think the pieces by and large are there. There's some fairly simple low-lying fruit to hit in putting this together. I didn't quite get the generators done. There's the span question. But otherwise, I mean, Pratt kind of gets us most of the way there. The other thing I wanted to point out to you is LineDB, which is a command line file manager in Urbit that Uqbar has started working with, that I've poked around with some, and they've been using it internally in Uqbar. So Pratt is just kind of a proof of concept version control. And it's not really a full file manager, right? Because there's a lot of things on the file system it doesn't purport to do. But LineDB is starting to build out these concepts in more depth as well. It's short on documentation, so go find someone from Uqbar and shake them by the lapels until they publish some public documentation, which they seem rarely inclined to do at this point. I think it would also be feasible and interesting to actually try and do a Git client on top of Clay. I think that's a fairly big project, but Clay could do it. You know, like if you wanted to actually write that up as a bounty, or, you know, like, is this worth building? I think we could build it. And I think it would probably be worth a few stars, like 5 stars or possibly more, depending on how much work it actually ended up being. I think the value for having a Git Clay client would be immense. So I that would be an interesting, some questions about like how you'd handle marks and stuff like that for unknown file types. But I think it would be really cool, and I think it's actually feasible at this point. Any questions about Clay or what we've done, or why things didn't work as well as I'd hoped, and so forth? If not, I'll go ahead and stop recording.